Good evening, everybody. My name is Clara. I'm a student from the Astronomy elective course, and I'm here today to present a little bit about what we have been studying this year, which is the history of astronomy. Boa noite a todos, eu sou a Clara, aluna de Astronomia, e estou aqui hoje para apresentar um pouquinho do que a gente vem estudando nas aulas de astronomia, que é a história. First of all, it's important to state that astronomy hasn't started in a specific year or period of time. It has always existed. Practically, all the old people in antiquity studied astronomy. Some examples of this are in their constructions, like Stonehenge in England, ziggurats in old Mesopotamia, the Aztec pyramids in Mexico, and even in Brazil, with the Brazilian Stonehenge. However, astronomy started being really considered a science in ancient Greece. Aristotle, trying to understand the movement of the bodies in the sky, proposed the elementary laws of motion, which stated that body could only move forward and around another one. However, there were still some planets in the sky with retrograde movement when seen from Earth. And to explain that, Ptolemy proposed the epicycle theory, which stated that some planets moved around Earth and others moved around other planets. So, orbits would be like small circles around a big circle, with Earth in the center. Aristarchus also tried to understand this retrograde movement, but he came up with a different conclusion. The planets, including Earth, orbitated around the Sun, and so when we see one moving backward, it's actually just Earth that is surpassing them. At that time, also, Aristotle's calculated the circumference of Earth, in conclusion its size. At the Middle Ages, there weren't much astronomy studies. They came back more strongly just by the end of it with the Renaissance and the beginning of modern age. Copernicus studied Aristarchus' heliocentric theory, extending his ideas about it. So he determined the order of distance of the planets from the Sun, being Mercury the closest, and then Venus, Earth, Mars, Jupiter, and Saturn. Those were the only ones that could be seen from Earth with naked eyes. Tycho Brahe decided to test Copernicus' heliocentric theory, so he spent his whole life observing the night sky and writing down his discovery. He amazed a large number of stars and planetary positions. When he died, his student Kepler kept his work, and with that he could conclude definitely how the movements of the bodies in the sky were. He summarized his work in 3 laws, the laws of Kepler. The first one states that the celestial bodies move in ellipses, with the star in one of its focus, meaning that the planets are not always with the same distance from the star. In some moments they are closer and others more far away. The second one states that the movement is not uniform, meaning that its velocity is not always the same. When the planet is closer to the star, it moves faster. When it's farther, more slowly. The third one states that the square of the period of the planet is proportional to the cube of its orbit axis, relating the size of the orbit with the time it takes to complete it. Galileo Galilei was the first one to use a telescope. With that, he could observe the moon's surface and discover 4 Jupiter moons. Galileo's idea inspired Newton to study more about movement and gravity. He also divided his work in 3 laws, the laws of Newton. The first one states that an object will not change its movement unless a force acts on it. This characteristic is called inertia. The third one states that a force on an object equals to its mass times its acceleration, relating force with how big and agitated a body is. The third one, known as the action and reaction law, states that when 2 objects interact, they apply equal forces to one another, but in opposite directions. This discovers he could describe the orbit of the planets and the moon. Almost 200 years after it, we had Albert Einstein, which was one of the greatest scientists of our time. He introduced a different way of looking to the universe, proposing the theory of relativity and explaining that gravity is not a force, but a curve in space, and that's why things around a bigger body tend to fall closer to it. However, astronomy hasn't stopped there, and will never. Each day, we have new discoveries and experiences. Some examples of scientists from our time are Stephen Hawking, that studied dark holes and solved the information paradox, Caroline Shoemaker, which was the person to amaze the largest numbers of comets in history, and Katie Bowman, the one responsible for the development of the software that took the picture of the first dark hole. This proves that there's still so much to be explored in the universe, and we are only beginning. Thank you for your attention. Obrigada pela atenção de todos.